Hi, I'm Roger Ordman with Ordman Software. We are witnessing a great change in the automotive industry, where a lot of the focus is moving from the hardware of the car to the software. Software-based products and software-based services, such as the in-vehicle infotainment, the rear seat entertainment, the rear view camera, the climate control, and so on, are all software-based. In order to incorporate all of these software products and features in the car in an efficient way, one of the things the industry is looking for are means of hardware consolidation. What Ordman are demonstrating here today is our Type 1 hypervisor that is used to take a single, strong, powerful hardware platform and run on top of it separate operating systems for separate functionality. In this demonstration here, we have a TI platform that is running both the in-vehicle infotainment and the digital cluster side by side on the same hardware platform. The digital cluster is running on Linux, and the in-vehicle infotainment is running on Android. These are fully functional operating systems running side by side, utilizing the hardware in a direct manner so that each one thinks it has complete control of the hardware and has all the resources required to run its application independently and separated one from the other. If the Android receives an application that is a malware or even a virus, it must not affect the real-time operating system which is used for mission-critical functionality of the car. We also show how the manufacturer can control which operating system gets a higher priority when accessing the hardware. For example, in this case, the digital cluster should always get a higher priority than the in-vehicle infotainment. If the navigation freezes up, it's maybe not the end of the world. If the speedometer freezes and gets stuck, that of course is a problem. This has to be guaranteed. What I will demonstrate now is if I run on the in-vehicle infotainment an Android game, we have split the graphical processing unit resources amongst the digital cluster evenly and the in-vehicle infotainment game. And we see in fact the performance of both is perfect. If we decide to give all of the resources to the digital cluster, we can now see that the in-vehicle infotainment is being starved. Another interesting part of this demonstration is if an application is downloaded that tries to take full control of the CPU, maybe a buggy application that is a resource hungry, is trying to take 100% of the CPU. It is only taking 100% of the CPU which is allocated to it. Because we gave a higher priority to the digital cluster, this is still running smoothly. So no matter what happens here, no harm can come to the performance that has been given a higher priority on the digital cluster. Using the cloud-based software management center, we can access remotely the car, get an inventory of all the software elements on the car and the versions, and even then choose to send to a single car or a group of cars updates to that software of the car. The car is more complex than the mobile phone because there's different operating systems and different hardware platforms that all include in one device, which is the car. Ordman supports, in addition to the Android and Linux we've seen here, QNX and other operating systems, and includes the TI, additional hardware as well. For more information, contact us at www.ordman.com. Fill out a contact us form. We will contact you and we'll be happy to give you more information about this and many of our other solutions for the automotive industry.